we entered the dark era of the UFC now, because
Uh,
everyone who's a champ is boring, quote unquote
yeah,
boring, because of the
yeah.
wrestling. But
Anyway, starting off our weekly stream here with a little MMA talk. But hello, everybody. We got a couple people just joining on the viewing side. Welcome back to our weekly stream for the Epiphyte project, open source miniature direct air capture. And had a pretty awesome week. Right now, I'm actually at University of Pennsylvania. I was on a panel today for the Road to Removals event. So a lot of talk about DAC and a lot of notable figures in DAC and CDR world. And David won't be with us today because he came and he's watching one of the panels. But I figured I would share a picture real quick of me with the thing. That's me pretending to get my head stuck in it. But it was it was fun to finally see it in person. And we did get we did pick up some extra stuff here that I had hoped to. So I got the two parts of the new sensor, which they're not using. So we can cross that off our expense list, which is good. I went ahead, even though we don't think it works with a monolith, but I figured I would grab a few of the bottles of, this is the Luatit sorbent, Will, that we were thinking of using prior to discovering the monolith option. This isn't good for monoliths, I guess, because if you heat it up, the heating process for the sintering or whatever is too high for that. But I also had, I know monoliths, they do sometimes use zeolite. So this was the original sorbent we had, and we accidentally ordered 4 bottles of it. So I have an extra one of those. So if I don't get arrested and thrown in jail trying to bring this on a plane tonight on my way back to Austin, I'll give those over to you and add that to the bunch of things we might tamper with. So a few things to discuss today. I put a little kind of agenda together, but since looking at the Discord about 15 minutes ago, there's one extra item to also look at. On the UPenn front, which was also cool, is a early member of Open Air who at the time was at Washington State University, Alina. I just bumped into her at this conference, and now she's doing a PhD at UPenn focused on sorbents. And she introduced me to a few other students who are here. And so now we have some interest among some students to potentially keep the UPenn site alive. And I am talking to some of the UPenn people today after the conference about next steps about making sure we keep UPenn active. And then I was hoping Charles and Thomas and Will, just to kind of go over a little bit about the meeting, which as I was telling Thomas before we started, I was just blown away by how many students showed up for that first DAC meeting. And I also wasn't aware of the way in which you guys have these sort of subgroups. And I think that those map on quite well to the needs of the project. So I thought I could have you guys give me your impressions of that. And then some of the design stuff for the current model we can talk through, including something that Ling flagged on the Discord, which was I did the math on the pricing of the chimney parts a little bit differently than her, so we can just open that up. And if I had to bet my life, I would say Ling is probably right, but we'll take a look at that. And then if there's anything else to bring up before we get it going on that, though, is there anything, Ling? I also saw, we could talk about it when we get to components, but you posted a couple things on the Discord as well for some other parts. It looked like.
I think we need to make some phone calls, and I think it would be good to shake down the task list for that, and talk about like who to call and what information we're trying to get.
Yeah. Do we think we want to do for that? I was going to ask one of the things I didn't put on the agenda there, but with the GitHub, we have that sort of project kind of Kanban type of thing. I didn't know if we wanted to just go ahead and use that, or just use something, just create a spreadsheet or use some other task tracking thing. But I agree, we should, particularly having gone to the UT event and seeing that there's a lot of people potentially to work on different components of this, that we absolutely have to have a to-do and task tracker for it.
Yeah. With a bunch of people who are students, it can be kind of tough. Are you still using, like, what's that Kanban thing that you used to use?
It's too expensive, but
okay.
if we could use the one on GitHub because they have a similar thing, you know.
Let me look at it and get back to you like in a few minutes. But I think that's probably a good idea. I don't think like a spreadsheet is easy to use, but it's not so good when the task list becomes humongous.
Yeah. Yeah, I mean, I think if we break it up by subgroup, you know, I think we'll talk about that a little bit. And I'll have Thomas and Will and Chaz kind of speak to that a little bit. But there's already sort of a structure at the UT Net team, DAC team, that, again, it maps on pretty well to what we're trying to do here. So we could do a to-do list that sort of separates the different work streams a bit, that makes it less, you know, unwieldy. But let's go ahead and go to that. And you know, Thomas and Chaz and Will, I didn't know if you guys just wanted to just maybe summarize. We had this great first meeting with people, students who were interested in DAC and the Epiphyte project that me and my son popped into at UT. And it was a huge number of people there. It was like 30 people at least. And so I didn't know if you guys wanted to just, you know, summarize what was discussed, but also, did you get any other feedback? We did have a bunch of people join the Discord, actually, who I directed to the Epiphyte channel, but didn't know if you guys had anything to share as sort of a postmortem on that meeting.
Yeah. So Chaz did count how many people were in the room, and there was over 40 that showed up for the meeting. It was really, really good. We got a really, really good turnout, and I think that's a lot to do with, I think that our outreach chair is doing a very good job, as well as I think just in general, carbon capture is getting a lot of attention from a lot of majors of people who are just excited to get hands-on as fast as possible. We had
from my experience, that number will probably be cut in half after the first meeting, but
that is correct.
That's okay. 20 is still a lot.
20 is awesome. 20 might even be in some ways better, more controllable, but just to see that level of people come out of all different engineering backgrounds, there's some CS people. It was really something.
You're absolutely right. In the last year, the same thing happened. Well, not this many. We had like 30, and it got cut down in half about. Or maybe like 25 or so. But whatever. But you're right.
Good.
You are correct that it does get cut down quite significantly. But it seems like a lot of them are very passionate and excited to work with. We discussed just generally the flow of DAC, or the flow of our DAC team here at NET. I'm sorry I didn't know that you weren't aware of our sub teams. I'm sorry, I just must have slipped our mind to mention it to you. But yeah, generally in the past, what our sub teams have been is we split people up into mass transfer, chemistry, programming, and sequestration, just because that's the best way to organize for the carbon farmer, which is the previous thing we were working on. And we were talking them through that. We mentioned how that might shift at the beginning here. Chris is talking about that maybe they do fit really well. But it just generally, I warned them that they may be a lot more heavy on mass transfer to start with, because that's more like the physical building and stuff like that. But yeah, it was a really good turnout. We talked a bunch with them. I did confirm as of yesterday that we do get that workshop space. That is a guaranteed reserved space now. It was a little in the air, but now we're for sure. We have an open workshop space after it that some of the students came and saw. And yeah, that was about the summary.
What's in the workshop, Tom?
So it's in the building next door or across the bridge. I'm so bad. I always mix it up. One of them's the ECJ, one of them's the ETC. It's whatever the other one is. But it's a small like open space on the 6th floor that we cleaned up last year. And in return, they let us use a corner of it. So it's like a little physical space to actually place the machine and build and put things together instead of needing to keep that at somebody's house or another third party. So yeah.
Just a couple of other things on that too. The schedule that you had shared is it's regularly Thursday meetings, right? Weekly, and then there's some stuff on Sundays too, right?
Right. So the general flow of the DAC team is that from 5 to 6 we're gonna meet, and that's when kind of the sub team heads all discuss what's happening inside of their sub team. We communicate with each other and decide like reallocate responsibilities and things like that, or timelines, etc. It's like the time for collaboration. Most of the work is on their own time. Just the main DAC meeting from 5 to 6 is the time to gather and discuss things. Have Will nerd out about the chemistry. I'm just kidding. It's very, very helpful. It's a joke. but have like every team like discuss what's going on in their team, process like that, and then from 6 to 7 immediately after the meeting, it's reserved time to go up into the workshop. You can go up to it whenever you want, but that's like the specific time we're all going to be there that need to participate in that. And then on Sundays, usually for like a significant time block, we have a dedicated time for students to come and work with each other. Even though it is technically on their own time, it is like a dedicated time to come and speak about it.
Cool. Can people just pop into that room at any point if they wanted to work on something, or is that pretty much open access?
Yeah, the Sunday studies for 3 hours that we're there. Usually, right now we're doing 10 to 1. That may change. And you can pop in or pop out whenever you want. You don't have to be working on DAC stuff if you want to just be around in case someone needs to ask you a question about what you're doing, and just be working on other stuff at the same time. It's a good time, and I buy food for most of them, so dollar slice. It's king.
Very cool. Great. And then, go ahead.
I'm just curious about the sub teams because I think I don't understand the naming of them, and maybe like you think that I may have better suggestions, but I'm not sure if I do. I'm just curious. You don't have to talk about it now, but I would like to learn more at some point why it's divided up like that, and what each one does.
So it's pretty short, so don't worry about it. I can talk about it now. It was because the machine we were working on last year, the Carbon Farmer, was very much kind of divided in that way in terms of its construction.
Okay.
Like mass transfer be centered around the heating, the heat swing, the physical airflow, and just energy optimization at that point. The big thing on the Carbon Farmer we were trying to optimize was the automation side of it. So that's why there was a whole team like heavy dedicated to like programming and soldering and rewiring and all that stuff, organization.
Okay.
Will was being incredibly impressive with the chemistry side of things and needed a team, or he allowed a team to help him out with the hands-on experience. So that's why we had that chemistry team. And then sequestration, because just optimizing the algae, seeing different kinds of algae we could use and stuff like that. But that,
okay.
Yeah, but that absolutely can change in terms of the structure.
So mass transfer is more like mechanical, and then sequestration is more like biochem.
Yes, that's correct.
And then automation is more like firmware, I would say.
Yeah, it's like programming and things like that. Yes.
And so it's hardware, software together.
Yes.
Mating software with hardware.
That's correct. Yes. Yeah. Again, that we did say that early on. I know a lot of the. Sorry, say again.
I understand now.
Okay, great. Thank you.
Cool. And one thing I do think, Tom, is that because we have those subgroups and because we have people, it can change the sort of scope of what we can work on a little bit. Like we've kind of looked at, if there's a group of people that are really interested in the sequestration part, then that means there's a lot of questions about how are we going to do this mineralization, right? What does the chamber have to be like? What heat is required? I did some research on that to anything that can accelerate the reaction. Are we going to use brucite or wollastonite or, so if there's a group of people that are really, really like stoked about that part of it, to have them thinking about and working on that, to sort of set the stage for it. That means we can bring forward that as an element of the project.
Okay.
Yeah. So I think also the software part, there's the automations of the system itself, but then there's how do we get the data reads from the sensors to spit out somewhere, ideally on a very simple, website. If we have enough people that are CS people that are interested in that, why not start to think that through right now? Get them to really understand, the sensors and the software that we have already for that. So that was what I was excited about. Like looking at the number of people in the subdivisions, I was like, oh, we can do some of this stuff a lot faster, I think.
Okay. So maybe instead of what I was thinking about, like adjusting the sub teams based on what our current project needs are, you'll want to maybe adjust the project plan to the sub teams we already what people might be excited about.
Yeah, I would say as long as those people are interested in it, we have a destination that we're trying to get to. The only reason why we're slowing that down, there's no reason to not think about the mineralization at the same time as the other one if you aren't as constrained with the number of people. and maybe it's just that they explore that and kind of do a basic concept brief, and that's enough for now. But maybe they discover something like, all right, well, let's see if we can make that. You know what I mean? So I just want to say, like, we don't need to think about it all has to happen sequentially, where next semester the sequestration people can do sequestration stuff with it. They might be able to do it in parallel with us right now, I think.
That's a good idea. Absolutely. Yeah. I think that will make the that also help us when like I said, Chaz and I want to crack down on this to-do list kind of thing to start people going. That will help us as well to organize that. So that's a good idea.
And I did have, there was a bunch of people that joined the Discord, and one whose name I'm blanking on right now. I'm sorry. She actually joined I have like office hours a couple times a week, and she showed up for that. So we talked. So there definitely seemed to be some enthusiasm. And before we just move on to the next agenda item, I didn't know, did you hear from any people who attended at all, or any sense of continuing interest, or not sure if you got any feedback at all?
Yeah, I mean, I did get a few messages from different people asking me about more details. I even got some people who missed the last meeting who want to come to the next one. Yeah, I mean, it's in my experience, the people who do want to stay are going to stay for a while because they are passionate about it and excited about it. That's how it was with the current firm. We didn't get that back from China for the entire, second semester or so, a little bit longer, but like generally. But they were still happy to be there and to work and to things like that, do stuff like that. So in my experience, yeah, people tend to stick around who like, if they stick around for a bit, they're going to stick around for a while. So.
Okay, fantastic. Great. All right. One thing I found out, Ling, I heard back, I had done some research and then I heard back from Kirsch. They do use the cordierite monoliths, by the way, the ones that we were researching, not Illumina. So we can get more information from him about the compatibility of those two. But you had a question last week because I think you use Illumina monoliths, and we had been assuming cordierite. Both are available, as catalytic converter filters. But so anyway, I just wanted to flag that.
I don't have a strong opinion.
I don't even know either. I looked up one. One has definitely there's big differences in thermal conductivity apparently between the two of them. So.
It's not a big difference. Whatever Will thinks will work better. I don't feel like there's a huge risk with either one. So.
Okay.
Yeah, I think really the only thing about the cordierite versus Illumina is that for all the stuff that I've seen in literature, they use specifically Illumina to graft the PEI or whatever like MOF you're trying to use onto the monolith. So if it's made out of cordierite, I don't really remember if that's the one that has like all the minerals in it, but a small portion of it is Illumina, but it has like magnesium oxide and all these other, I think there's like iron in it and stuff. I think it's cheaper than Illumina, just a pure Illumina monolith, but there might be issues grafting our adsorbent onto it. So that's the only issue that I can see. If the cost isn't too much, we could test out, like, I was actually going to ask you, Chris, if we can just go ahead and just buy something now, because I do have some slides to share, but I want to see like what a big scale monolith would be able to like just get my hands on it and see how it can actually work with wash coating the PEI onto it. Because it might be a little bit challenging just doing it, let alone like setting it up inside the actual unit and everything. But if it's not too much, cordierite might be a good option if it's cheaper. But I prefer Illumina if we can get a pure Illumina monolith. Yeah, what are your thoughts on that, Chris?
My thoughts are your thoughts. Yeah, not for me to say what's better. If you did want to have a conversation with Kirsch just about why they use that, if that's helpful, but otherwise, if you use them and you think that Illumina is good, the cordierite will be cheaper, I think, although not much. I mean, the one that I did look at, I got a ton of responses back from suppliers on Alibaba. I posted it, and I haven't even looked at all of them. I had like 15 responses from various different manufacturers in China.
Okay.
So we'll take a look at that. I think one thing that would be fun, Will, is that maybe it could even be brought up in the next meeting, as a to-do, is to just start kind of picking up where you left off with MOF's last.
Oh, sure.
And just start testing out the PEI and things like that in a little thing and just see how well it works.
Yeah, I don't want to like necessarily just burn money. I know that's sometimes a part of this stuff, but like, do you think it'd be too much to buy like a small monolith that is cordierite and then one that's Illumina and just see like how well we can graft the sorbent onto it? I think that'd be a good. and then we can scale it up. If we can
Yeah.
see that cordierite is fine, then we can buy a big cordierite one.
Hurt.
Or
Wouldn't hurt. Yeah.
Yeah, let's do
We'll
it.
learn a lot from a small experiment.
okay,
Yeah.
and I really don't know how the shipping works with these things, especially if it's like from Alibaba or maybe some like domestic company. But I've just in my experience
You
with
can-
all of this, like
A lot of those listings, they will send you a free sample, and then we just have to pay collect shipping, whatever that means. It could be very expensive. I don't know, but it's free basically.
oh really? Oh okay.
Yeah,
Get that.
you can just request a small piece, and then you just have to pay whatever the shipping cost is.
Oh, so they can send you like a small piece of like cordierite or something, and
I think so. Like
Okay.
like not I think a small monolith even.
oh really? Okay, that'd be pretty cool then. Because the only issue that I usually run into with like anything that I'm doing with like chemistry wise, and I need to order something, is waiting for the thing to get here. And I've never really bought any like Illumina stuff, and also I think depending on like the size and how much of it we want, it could take a while to get here. I just really don't know. So I hate to say like, hey, let's just buy it now because we're not super sure which one. And it's like let's buy two of them, like the Correa and the Illumina. But I think that's probably the first step, and then once we have a good idea where or how that works with Illumina or Cordray, then we can start like we can go off to the races after that once we decide which one. It's kind of I feel like we're in a weird gray area right now. It's like we're not sure which one to use yet. I do have some preliminary stuff I wanted to show, but yeah.
Are you guys
why
good?
don't you do that? Yeah.
Are you guys good with Discord? So I told Chris earlier that I'm gonna probably laid off soon. So I'm gonna have a lot of time on my hands. It's not a bad thing.
Okay.
Because I have
You've been itching for a while, Lang. It seems somewhat ambivalent about your work situation, so maybe it's
it's kind of bad. So I'll have some time to like seek out. Right now I'm in the office, and I think people are just gossiping because we know the end is near. So I might as well just go on Alibaba and like look up listings that have the two types of monoliths. Oh, but a fair warning that I may travel at some point, so I may not be able to make some of these calls for a few weeks. But that's the downside of my layoff for open air. It's not really. I don't see it as necessarily a downside. I'm pretty like far into my career. I'm older than I look, so.
Come to Austin. Come
not
travel. Come to Austin. Come swing by.
Yeah, I thought about it. And I have actually my boss and I are friends, and like he lives in Austin, so
perfect.
he's also like excited to hear that you guys are doing a build in Austin. So still thinking about it. Nothing's for sure yet. Like the layoffs are not for sure, but very likely. So anyway, I'll look up. I'll make this a to do item. I'll look up like listings of free monoliths of the two different materials. I'll send it to you, Will, for approval, and then when it looks good to go, then Chris can pay the shipping fees, and then we'll get them going. I'll try to do this in the next day.
Yeah. Will, do you think
tonight, so.
We're looking at the catalytic converter products because they physically are a better fit for what we want to do with the machine? But for testing purposes, like those little monoliths, can you get those from like Sigma or from some other supplier? Like the ones you use at the lab?
Yeah, so I kind of ran into an issue because I kind of needed a powder to do one of the analysis I wanted to do. So I started doing stuff in Illumina powder. I'm pretty sure I could probably find Cordray powder somewhere, online, like pretty easily. And I can kind of explain more like why it had to be a powder now. Obviously, it's not going to be a powder once we put it into the actual unit. It has to be a monolith, but it should serve it should behave the same way because they're both going to be Illumina powder versus Illumina monolith. But I just need like a powder, I guess. Like Cordray powder, I could probably find that myself. But in terms of actually doing the whole wash coating, though, like physically doing it, I just found that it might be kind of difficult. Just playing around with the powder itself, I found that it was a little bit hard. So then actually doing it on like a large scale with the monolith might be a challenge. Actually, like it might involve some a little bit of work to actually do that.
Okay, just let me know though. But I'll be I'm the procurement guy. So when you get to a point where we have to order stuff, just let me know. We will have just like with the last bomb that we did for the first one, it was just really big multi-tab spreadsheet that the one that we have now will turn into once we make decisions, and then we put the supplier, has it been ordered yet, what's the cost, and everything can just get shipped directly to me, to my house, and then I can just bring it to meetings.
Okay, cool. That works. Awesome.
Okay, cool. Now, before we get into your slides, and then we'll also look at the prices for some of the components that we were looking at. There was a discrepancy between what me and Ling added up. I just want to quickly, let's just look at the projects thing real quick on GitHub. Is that okay?
Yeah.
Ling?
Yeah. We can just. I think we're probably just looking at different types of chimney piping, and that's why the prices are different. I'm looking at double walled. I don't think the single wall can sustain the amount of heat that we need to hold.
All right, let's talk about that just real quick first, since you just brought it up. This is the spreadsheet that I have. If you guys can see that. And so the parts that I put in there so far is
Oh, you
one.
put double walled, yeah. Okay.
Yeah, this is the fourth tab on the Build 2 Austin one. I had an 8-inch double wall black pipe, 48 inches long. Those are 267. We need
I
one.
can't really see your screen for some reason. Can
Maybe the lag.
Yeah, I just see a black box.
Oh, really? Okay, 1 second. Can you see it now? Really?
No.
I can see it shared on mine. I wonder why that is.
It might be a Wi-Fi thing.
That's pretty good Wi-Fi. Let me see. Let me try this. Can you see it now?
No.
No. Oh yes.
I'm looking at the screen share. So if I go like this, might even be better. Can you guys all see it now?
Yes.
Okay, cool. So let me zoom in on that a little bit. So I had the 48-inch double wall, 8-inch interior diameter, 48 inches. Those are 267. There's one of those. And the other parts I put, this is actually 8 inches.
Yeah, I see what the problem is. So you have basically the most basic setup, and I'm thinking about making that bypass that David suggested. And so it would be a lot more because the bypass parts are very expensive. We need a couple of the tees, and each tee is like almost $300.
Why do we need a couple tees?
To make the bypass, we need yeah. Like we need one on each side, but then we need an extra one that is originally supposed to be for the vacuum versus fan split. But I think maybe we potentially don't need to have the bypass be made of metal. It can be made of something else, but we'll have to figure out how to interface the chimney piping with whatever else, right? Like the PVC or something. So anyway, for this reason, I'm thinking about so whenever we're thinking about an engineering problem, we don't want to just think about cost, but we also want to think about complexity. And whenever we can reduce complexity along the way, we want to do that. And I would like to just call the clay people and ask them about the properties of that thing to make sure that it's absolutely not possible to use it, because if it's cheap, then that's great.
So just using clay, but using it with 3D printing, or just looking at the material?
Just thinking about like if clay can sustain a vacuum, because that seems to be suspected as a problem. And if we can cut down some of the cost and then move the cost toward making the interface between the housing and also the bypass, or a T split or whatever. I'm just like weighing all my options. I don't really know that it will work.
Do you think, Ling, with the bypass, just so I can visualize that, are you thinking, oops, sorry, that's what I meant to do. Let's just look at this for a second. Mm-hmm. Would it be almost, see where it says pipe? Is there a possibility you could have almost like a heat rated flexible pipe that we drill and then put gaskets around that could go from where the pipe is down to the bottom right above the heater?
We need a coupling, like some kind of screwing, or we have to weld. Those are the two options. Wait, was someone going to say something? I thought I heard someone talking.
I was thinking that here with the UT team, we could probably build it without the bypass first and then add that in afterwards because I know, at least for me personally, we have capabilities of like retrofitting stuff. We can make the welds, we can make the cuts. That's not really an issue on our end.
Okay.
Yeah. Specifically, actually, we have one member of the DAC team that spoke to me, who she actually works at the Texas Invention Works, which is like UT's on-site like machine shop and 3D printing and laser cutting and all that stuff. And she offered like private training. She said she could set us up trainings like a lot faster than a normal system if we need to get a lot of people on that kind of soldering or uh, not welding, but like machine shop and cutting and things like that. Like that's doable here.
Okay. I think we can always jury rig stuff together. But it's not. It may be like very funky in structure in the end, and so I'm just thinking about doing things right the first time. That is also like one of my principles. I'm okay with doing things not right the first time, and you know, if it's a quick proof of concept and if it's like retrofittable, it's fine too. But we should talk things through.
Yeah.
I just think it might be simpler as well if we start off without the bypass. Um, that's my only thing too because it'd just be a little bit easier.
It is quite possible if the chamber is bigger. Sorry. Like we may find that we may not even need the bypass if the
Right.
chamber is bigger. Also,
Is that part where the bypass is supposed to go in? Is that going to be a like connected, welded, or like when it was originally made, like cut like piece, or could we potentially make that kind of like a screw on and attach it? Like, is that plausible?
yeah, I think that's the difficult part that I'm thinking of. You have the body of the pipe, and then you need to create a hole and make sure that things it's like feeding out of the hole in a somewhat airtight manner. It doesn't have to be like 100% airtight, but it has to be pretty airtight, right? Because we're gonna have to hold a vacuum. We need to make sure air doesn't leak. And you have a cylindrical like pipe body, so to get a screw on, you need like a fitting that allows another thing to screw in, and that's the part where I'm hesitant to retrofit. Maybe Will has better ideas. So either like screwing on with an existing like feature, like a screwing some threads, sorry, words, or welding on would be the best. I don't have like welding experience, like very little. I have like welded ones, but um, yeah, those are like the best ways to do it for air tightness.
I'm thinking we could also maybe use clamps in some way. Like you'd have to make the hole first. Like I'm just assuming we'd have to drill a hole in of whatever size, and then whatever tube that goes into it. You might be able to put clamps onto something that can hold down to the body, like around it maybe. And I don't know if that'd be like vacuum tight, or I don't know if that'd be if there'd be leaks there. Even with the weld too, you might potentially have a leak, but that'd probably be the best option. Even if you just weld on, like so you make the hole and weld out like a little tiny part that juts out, like a small piece of pipe, and then from there you can clamp on the rest of it. That could also be an option, but that's still involving
Yeah.
as well. So the screw option might be a little bit too tough because I feel like that would just leak because you're gonna have holes somewhere where the screws or the bolts go in. So I don't know if that could work though. I don't know.
Yeah,
When
that's why
you,
I was thinking of using the T's. Sorry, go ahead, Thomas.
I was just gonna say with the screw-in option, you can have I forget the name of it, but like a liner for the screw that kind of puffs it up a little bit, so that when you screw it in, it's basically airtight. Like
yeah, it's like Teflon tape or the air version.
Okay.
Oil and
is for air too sometimes.
Oil and gas uses Teflon largely in like a lot of screw-in points, and I hope that's airtight for what they're doing.
It should be good. Yeah, like the thing that we have now is hardly good enough. So
I think it comes down to what's cheaper. Are the clamps cheaper or is the screw-on cheaper? Because I think both would probably, with the right like materials, including like with like shared materials like tape and like Teflon and stuff like that, we'll probably get a similar air tightness. I think it's just about which one's cheaper.
I also think about modularity and like retrofitability. I don't know if that's a word. Or like reassembly. So, because a lot of times we have to reassemble things, and we want it to be reversible.
So I think welding wouldn't be the best. If we have something where, as you were just describing, it's a tube and it could be, whether it's an
Yeah,
O-ring, some kind of thing we could put in there that would make it.
we
But
can
you were
weld, we can
just on,
weld stuff and just plug it up.
yeah,
Find that so much, but welding, it's you gotta find someone who welds a lot. You can't like not anyone can weld.
Right. Yeah. It's a skill.
yeah. Just so I'm visualizing properly, though, and this looks way more like a bong than I ever thought it did before. But when you're looking at this here, should I be envisioning a? Here's Tanya. Should I be envisioning a almost like a the handle of a coffee cup on the right side would go out like that
Mm-hmm.
from the
That's what I
top?
was thinking.
Is that
Yeah.
what you're thinking? That's right, Ling?
Yeah, and the
Okay.
fan would actually just go below the heater. You wouldn't have any more separate fan and heater things. The fan would blow through the heater, and then your dampers will be outside the fan. And that's so the bypass is supposed to help eliminate the fan slash heater discrepancy. Sorry, I know it's
You mean the second fan you were talking about,
you
right?
can't
The one that works during the desorption, like just to circulate the air?
you may still need a vacuum branch. That's why I was thinking 3 T's, 2 T's, one on the top, one on the bottom for the bypass, and one extra T for the vacuum and the fan, the vacuum and the damper.
You
Which is
still
very,
you still like this, right? We have the fan on the side just so it's out of the way of the heater, like the main fan that we use during the absorption phase.
I think the fan has to blow through the heater. A fan needs to blow through the heater.
Right. But here was a problem though, because we need to have another fan, right? Because the dampers are open during this
Um,
phase.
yeah. You're talking about without a bypass, the coffee cup handle.
Yeah, the way I did it here is if you have the bottom is sealed, you have a heater below it, you have the monolith drops into the pipe, but instead of having the fan on the top or on the bottom, you have it on the side so that when you need to, you can pull air and it'll pull it through the monolith. It just doesn't get in the way of the heater. The other heater you were talking about was more for air circulation while it's heating when the chamber is sealed, right? So it's hard to use this fan if it's on the outside of the damper
Right.
at that purpose.
Yeah, in this particular illustration, you would need another fan to help send the heat toward the other side.
And you think like the thing I looked at with the chimney one, with the chimney, we had there are fans that are sold by that company for like $89 that are high heat rated. I deleted it from the tab there because I didn't think we'd need it. But there are ones like that that are relatively, not super high power, but probably enough with the bypass thing, it being vertical and a little bit of fan is probably enough to kind of move the air sufficiently, right?
Could you put that fan back on actually?
Yeah.
Sure. Yeah, it doesn't hurt to have it on there, but we'll just like not use it, but it's good for people to see all the parts. So I think for the air to recirculate, it has to go somewhere. So I was looking at 8-inch diameter pipes, which you are also, which is the biggest thing. And if we can send the air down one side and then come back the other side, then that could work. We would have to test it because going to the monolith, I suspect, but don't know for sure, that we're gonna have some air resistance. And when the air gets to the other side of the monolith, it will be there will be less of its momentum, and then when you come back this way, there will also be less momentum. But maybe like when the fan is going it will create back negative pressure to pull the air in a circular fashion. That we somewhat have to test
Okay.
by understanding how the monolith behaves physically or modeling, which is not my strong suit. It is possible to do it without the bypass, but it's less predictable.
Okay. Well, when I was looking at the pricing, if we decide that we don't want to use, we don't need to go overkill and pay $700 for those two T things.
Mhm.
And if we could do it through some other way that we just described earlier in the call, my pricing came out, if you included a fan like that, which is $89, it's about $1,000, which is not too much different from all the parts we had to build for the last one, which were like $800. So that was what the only thing there's two of are the dampers.
Yeah, I think it would be good to get the opinion of everyone. So Will, Thomas, maybe the mass transfer team, maybe also David and Seth
Yeah.
to see um it so I think Will is probably team let's just try it without the extra teeth. Um let's just do it with one segment of the pipe and see how it goes. And I'm fine with that also. I think later on we can add more stuff. I don't think it needs to be 48 inches.
Okay. Well, let's do this because we're running out of time. We'll talk about the GitHub project thing.
Yeah.
I think we should just use that as our project management thing. It's functionally the same as the other thing, and it's just nicely right there with our own repo. So you and I will work on that next week. We can do that and start. We do need to start using some kind of a task tracker. We've already named a few items today. But let's get right into Will. If you want to share the slides that you prepared.
All right. Let's see if I can share screen.
Yeah, right below on the bottom there's a present between settings and invite.
Okay. Let's see if I can figure this out. Okay, I believe I'm sharing my second screen. It's like my Discord is open right now.
Yeah, right now
I see the PowerPoint.
Okay, cool.
There you go. Great.
So it's not too much. It's just a little preliminary stuff. Let me start off. Okay, are you guys still seeing the
Yes.
presentation? Okay, so this first slide, all it is just going over what PEI is. So PEI, just for like background for anyone who's like doesn't know or is just more interested, it's polyethylene amine. So what this is, there's two versions of it, but this one right here is the A. This is the linear version of it. All it is just ethylene. So just a little quick course of organic chemistry. When you see ethyl, that means two carbons, and poly just means repeated units. And this imine, this is just telling you that you have some nitrogen-containing group in the structure. You can see here that it has like these brackets around it. That signifies that this unit is repeating over and over and over. So it's a polymer. You can also have a branched version of it where instead of just having this nitrogen here, where usually nitrogen will have 3 bonds unless it has a charge on it. But when it has 2 carbon bonds and then 1 hydrogen like this, that's known as a secondary amine. And when you have a nitrogen over here, can you guys see my mouse, by the way?
Yeah.
Okay.
Yep.
When you have a nitrogen that's like this at the end that has 2 hydrogens and then 1 carbon attached to it, this is a primary amine. And then over here, you have nitrogen that's connected to 3 different carbons. That's a tertiary amine. So those are different classifications of it. But the thing that's unique about PEI is that you can have this branched version of it where you have all different versions, not just the secondary one. You can have the primary one, the tertiary, and the secondary in there. This all goes into like chemisorption of how the CO2 is actually adsorbed, but essentially you need these nitrogen groups to attack the CO2 and it'll form a bond between them. And that's called chemisorption. And that's a strong form of adsorption. So in the literature, everyone uses this PEI because it's pretty common. It's pretty like you can just buy it. It's not super expensive. But the actual chemical like makeup of it with all these nitrogens is what's really like appealing of it. So that's PEI. We had it in my lab. I don't know why necessarily. We just had some. Maybe someone a long time ago was using some. But this is it down here. And I played around with it before. I knew what it was. Most amines, like let's say you just had like ethylene diamine. So it's just this nitrogen here with a carbon here and then maybe like another carbon there, and then instead of here you have another nitrogen. That's like the simplest form of like a carbon amine that you can get. Ethylene diamine. If you just had that, that's a liquid. Most liquid amines, most of these amines, these carbon amines, these like alkyl, they call them alkylamines, so carbon chains that have nitrogens on them. These alkylamines are usually liquids at room temperature, but since this polymer is so long and there's so many attractive forces between the different molecules or the different repeating units of the polymer, you end up getting this like gel-like substance. And this is what kind of causes a little bit of the difficulty with working with it, because this this PEI gel, you need to dissolve that in some solvent first, and then you wash coat it onto your monolith. So I did this just like a very preliminary study. So in the literature, they say the PEI can be grafted onto alumina, and this is kind of like an important distinction to make, is that you can do other methods. Like for example, you can just like coat the surface and impregnate the surface where it's just intercalated onto the surface, but there's no real chemical bond being formed. It's just, you can think of it like being embedded onto whatever surface you're looking at. Or you can do a grafting method where you actually form a covalent bond between one part and then the surface that you're trying to get it onto. The grafting part is really important because that actually makes a much stronger connection. So when you're doing like the heat cycling and you're going through like many different like temperature swings of it and everything, you have less of a chance of taking off your adsorbent from the surface, which is really important. So PEI is really good at that. But to graft it onto it, it has to be through these nitrogen containing parts. So the nitrogen actually has to bond to something on the surface, which is why the alumina, which has oxygens, is favorable, because that can just directly graft onto onto the monolith if it's made of alumina.
Okay, so do you think that for wash coating for like cordier, right?
Uh-huh.
It's called wash coating. Do you think it's more of a physical? It's not chemical attachment. It's more of a physical attachment, or just layering it on top with
Yeah, I'm honestly not sure. That's why I'm kind of worried about the coriorite, because I
Okay.
think you might to a small extent get the grafting, but I don't think it'd be as efficient if it's just pure alumina. That's the only that's like my main concern. I think we can still do it, but it might degrade. Maybe we might see it like it might work the first wash coat, and then we run it, it adsorbs, looks all good, and then we heat it up, and then it just all degrades or something starts coming off. Right? I'm just really not sure. We have to test that out.
Yeah.
Are there
I'll create it like a thread with Yumi and Kirsch, just because he's a guy who literally like every day is doing one of these
Okay.
with cordiorite. So, and the way he described it is they just literally dip the monolith in the solution for a certain period of time,
Okay.
where it soaks into it. And then I think that the real bonding happens when you heat it up, is my understanding.
Okay.
I also dropped in, somebody shared with me, who the hell was it? Somebody on the Discord, another academic article about the monolith wash coating process for sorbents. It's an academic article, so I popped it in the comments there, Will, but that might be just totally obvious to you already. So I just wanted to add that.
Okay, let me just quickly check that one out. Or you said is it in the Discord, or is it on the?
I'll put it in the Discord too. It's also in the comments section here on the StreamYard, but I'll go ahead and pop it in the Discord channel for Epiphyte.
Awesome. Okay.
Hey, well, just a quick question about PEI. Are there any hazards associated with working with it at all? Or
Yes, definitely. So all of these amines, usually they're known to be carcinogenic, like almost all of them. So you really want to make sure you do this inside a fume hood. It's hard to tell, but inside of here, this is inside a fume hood. I'm not directly like trying to inhale any of it. It's not a liquid, so it's not volatile per se. But you definitely don't want to get any of this on your hands. On my gloves, it's like really sticky, and it just sticks to like everything, it seems like. But yeah, most amines are carcinogenic, so like cancer causing. So you don't want to ingest any of this, which includes like getting on your hands and then putting that in your mouth somehow, or like breathing it in, right? So you got to be super careful with all these. But
we have to be super careful. I didn't know that. So
I'm just expressing in terms of like, especially if the wash coating does come off, to be like when we tried to do the heat swing or whatever that you were talking about, like adsorb it and things like that. If it did come off, would it be still dangerous at that point, or would something about it being grafted on, like kind of falling apart, kind of dilute that problem?
Well, when I say it comes off, what I think is it would degrade, and
I see.
Yeah, so it might just like turn into like small like carbon nitrogen parts of it, and it will just like over time it'd go into the air, I guess. So we definitely want like an open environment for sure, which it should be. That's also like a concern though, that because it's just environmental hazard. But
Hmm.
it'd be small amounts coming off. Of course, you wouldn't want this running inside of a closed room. I wouldn't think.
It
Um,
wouldn't do much good there anyway, right?
right, exactly. So, but yeah, there is definitely like health concerns. But even with like all stuff, like even if we were using like the zeolite, like powder, or whatever the pellets that was before, like some of that the dust that comes off of that, you don't want to inhale it.
Right.
So it just kind of comes with the territory.
Okay,
This one
gotcha.
I will say is a little bit more safer than most stuff.
Okay.
Just that it's not volatile right off the bat. That's like number one thing. So it's not a liquid, so that's really nice. But yeah, definitely health concerns, and we can talk about that for sure. I can make a whole like thing about that too, about the safety on making these things, for sure.
Got it.
Yeah,
Thank you.
do a whole lesson on that. Make sure we look at whatever the best practices are and follow that absolutely religiously. So,
Definitely.
okay, cool.
So
Thanks for the organic chem refresh.
totally,
Yes, thank
yeah,
Very helpful.
yeah. This is the cool stuff. This is the stuff that I'm totally biased, and I think is the really cool stuff. And I
You
just,
got a compliment, Will, in the chat from Arbery in Barcelona. He said, really nice explanation. So I just wanted to give you that feedback.
Oh, cool. Sweet, thanks. Awesome. So I guess I'll move on to the actual procedure. So I was going to put this in the Discord, but whenever I go to this website, it tells me it's a not secured link. So I didn't want to like just throw this paper into like the Discord and people think it's like some weird phishing link. But I might try and find like a downloadable PDF of it or something that we can all just like read. But this article
You can print it as a PDF, upload it.
through Discord, does it let me do that as a
I
just a
believe so. I believe you can upload stuff.
like a file link? I was going to try and do that so everyone can look at it.
Or you can send it to Chris, and then Chris can put it in Google Drive and then link it.
Okay, I might just do that. Yeah, so everyone can have a look at this. But this was a really interesting article because it was kind of, it's not like a science, it's not from like ACS or anything. I found that it's from this like Eurasia Proceedings of Science, but I think it's a book actually, or it's from some kind of like actual like so it looks like it's from a journal, but it seems like it's from a book as well because there's an ISSN here. But regardless, in the actual body of it, it talks about how they actually put PEI onto alumina spheres. So they took small alumina spheres. It's like FB, I think it was like 200 or something, is what the brand name of it was, or the code for it. And it was just alumina spheres, and they washed it with methanol, and then first they dried the spheres using methanol, and then they dissolved by weight percentage how much PEI they wanted into methanol, and then submerged the dried spheres that were cleaned into the PEI solution of methanol, let it soak for an hour, and then dried it off, and then did the analysis on them. So I pretty much repeated their same procedure, but instead of using small alumina spheres, I just used alumina powder that I had in the lab. So again, we have like a bunch of chemicals that are just laying around from previous students that have been in our lab for like literally decades. So there's just stuff laying around from like all types of experiments. And I had some alumina powder, but it turns out alumina can be classified into different categories. So the stuff that I had was called Berkman 1, I think is what the classification of it is. And basically it's an activated alumina. So without going into too much detail of that, it's supposed to be one of the best ones for adsorbing stuff. I think they use it for like drying different, like, I don't know, like they put it in like desiccants so it can pick up water, I think. I'm not really too sure what it's really used for, but that's the stuff that we had. So I just took some of that powder, and I know it's alumina at least, so I thought it might serve a similar purpose with, or it might be able to be replaced with the spheres that they used in the paper. But what I ended up doing was I just weighed out 3 grams of the alumina powder. I washed it in methanol and then dried it overnight in 60 C under vacuum. So this is like the dried, clean alumina powder. And then I had 3 grams of this, and I wanted to do a 50% PEI by weight. So if I had 3 grams of here, I did my best to weigh out 1.5 grams of the PEI. But as you can see, it's like this gel-like substance. So when I'm actually pulling it out, it's super sticky. So I actually had like 2 scupulas going on, taking one out, and then I was putting it onto here. So this is like a little weigh boat. It's kind of hard to see, but there's like kind of yellowish, greenish substance in the middle there. That's the PEI, and it's really sticky. Again, this is in a fume hood, so gloves, you know, make sure you have all the proper PPE. But yeah, it's pretty difficult to work with. And one thing about articles, like scientific articles, is that sometimes they don't really describe how to do it. They just say like, use this amount, put it in methanol, and then do the next step. but then the actual process of doing it can sometimes be difficult, and that might cause like extra like random errors to occur, or like different variables that you didn't take into consideration. But I did my best to get 1.5 grams of PI weighed out into here, and then I used 20 mLs of methanol to dissolve as much as I could from this little weigh boat, and then put that into another beaker to stir it, and then let that sit for about an hour or so. And then I suspended this dried alumina powder into another 20 mLs of methanol, and I combined them together. And I let that stir for 1 hour as well. And then so I don't have the pictures for this, but then I went ahead and just vacuum filtered it. So I use a beaker funnel with a filter paper, put the PI or the alumina that now has PI that's been submerged in the PI solution through the filter, and then collected that, and then put that under vacuum to dry overnight. So this is kind of what I did earlier this week, and I basically came up with like alumina powder.
Well, I'm so sorry to interrupt you. Chaz and I have a class at 2, so we do have
Okay.
to go. No, you keep going. I just want to let you know I didn't want to leave without saying nothing. So
No, that's fine. Yeah.
Yeah, we're gonna watch the rest of the stream later once it gets uploaded, so we can catch the rest of your explanation.
Sure. And I was actually going to present this tomorrow at the DAC meeting as well.
Okay, perfect. Yeah, great.
Cool. See you later, guys.
All right, thank you. Thank you guys for meeting. See you.
So this is unfinished because I'm still waiting for the data to come in, but this was the next part where I would be doing the actual analysis on the sample. So this would be the isotherms. So I guess like going into like a crash course of what like gas adsorption analysis looks like. I don't have any nice pictures to show here, but pretty much all we have to do is collect isotherms for 2 different gases. One of them is nitrogen gas and then CO2 gas. An isotherm is just iso means constant, and then the therm is related to the temperature. So this is done at a constant temperature. And all you're doing is looking at the uptake of that given gas at a constant temperature over a range of pressures, starting from a low dose pressure all the way to a high pressure. So for nitrogen, we do them at 77 Kelvin. So you literally submerge your sample into a dewar of liquid nitrogen, and then you dose in nitrogen gas into the sample at low pressures, and then you monitor the uptake on a graph. And that's basically it. But the really important thing about these N2 isotherms is that at 77 Kelvin is that it can give you surface area and porosity information. For us, it's not like super important about the porosity really, because we're trying to make sure it's all like chemisorption stuff. So the PEI is doing mainly the most of the work in terms of the actual adsorption for the CO2. But the porosity information is important just to get like an idea of what the morphology of the material looks like, if you even got anything onto there. So the surface area you can see for like the base, like alumina powder, whatever the surface area is to begin with. And then once you add your PEI into it, I would expect it to increase. It might decrease based off of the actual like nitrogen interaction with the surface, but we should see a change. And that's the main thing I want to see. So what I ended up doing was I analyzed the alumina powder, so that's actually running right now, just by itself, with nitrogen at 77 Kelvin. And with now the dried alumina that has PEI onto it, I'll put that one next and see what the difference is in the surface area. So that's going to be the nitrogen analysis. I was also thinking of doing CO2 analysis on it. You can do a method at 0 degrees C. So you have a water bath that's at 0 C. And you can look at the CO2 accessible porosity instead of nitrogen accessible porosity. But again, that's not super important for us because we don't really care about the porosity per se. We just care about getting PEI onto there as much as we can. And then PEI does the chemisorption, and that does the main body of the work for the adsorption. But I think that'd be a cool analysis to do regardless, and it'd be interesting data to show. And then I think something that really would be important is doing like a room temperature isotherm for CO2 at like 20 C, and just see like what the uptake for CO2 is for the PEI onto alumina. So that data is going to come, but that's kind of where I'm at with this. Yeah.
So glad you joined, Will.
It's kind of a lot. Yeah.
Definitely filling a hole for us here.
I feel like I need a lap tour.
Okay.
Like a
to
proper.
Austin for crying out loud. Get a real one if you're going to be moving around. You can crash in my extra room. All right, I have to go down and watch another panel, but this is really great. I can't go tomorrow to the meeting, Will, just because of my son's soccer stuff. Yeah. But I will report back to me what you go over. But I think what we will do on our side is start to get a structure together for task tracking, among other things, and share that with you guys. We'll go over it next week on the call once it's set up.
Chris, do you want to meet separately?
What's that?
Do you want to meet separately?
Yeah, that'd be great. Yeah. Let's do it. I'll ping you later. I have to run down to the conference.
Yeah, no worries.
But
I'll message you my availability.
yeah, that's great. Yeah, let's do it. All right, fantastic, guys. Awesome, Will. See you
Thanks,
later.
Will.
Bye.
See you guys.